number 8. Number 8 is the crate on a ramp, and we are going to now we are going to try to cover 8, 9, 10, and 11 a little bit with the concept of a weight on a ramp, which is what I did also today in lecture. So here it goes again. So you have a ramp. So we are going first to the static case. Static case means no motion. But you know that you can have a crate of apples or something like that sitting on a ramp and not moving. So why is that not move? Well, it does not move because the forces are all balanced, and if I choose this to be my axis, then if this object has mass m, the free body diagram for that object is as follows. There is the vertical weight, there is nothing I can do about it. This is the direction of the ramp. There is a perpendicular force to the ramp that I call normal force, and this is, I've done many times, the angle of the ramp. Because the weight in this chosen reference frame has two components of the weight. One is this one, and the other one is this one. This is balanced by the normal force. This one tends to take the crate down. So if the crate doesn't go down, it's because there is an equal and opposite force to this one. That is your force of friction. And it's static, so that's the static friction. And these are the equations, and the equations are three. The first equation is the sum of the forces on the horizontal direction tells me the following, tells me that mg sine theta minus the force of frictions are up to 0 because there is no motion. The sum of the vertical forces tell me that the normal force minus mg cosine theta is 0. Therefore, this is what Newton's law tells me. But there is a third equation, which is the connection between the normal force and the friction force, because these forces, the nature of these forces has to do with the contact, has to do with this contact. And this contact produce forces. Some have perpendicular component and some have parallel components. And the connection is that the friction force, which always adjusts itself, the friction force is less or equal than a coefficient of friction, which depends on these materials, times the normal force. So the normal force is equal to mg cosine theta. That's the solution of equation 2. I take this, and now I go to equation 1. Equation 1 tells you that the friction force is equal to mg sine theta. But this one tells you that this number is less or equal to the coefficient of friction times the normal, and the normal comes from here and is mg cosine theta. So this one, mg cancel. The coefficient of friction, the minimum value of the coefficient of friction is the tangent of the angle. If it is greater than that, it will never go down. But if it is just that, it's when it's just start to go down. If you now push on this object with a force F and you make it to go up, this friction force becomes kinetic friction and opposes the motion, and the free body diagram now would be your normal force, your force F, your weight, your angle, and the friction force now come in this direction, and that's kinetic friction. So we are going to leave it up to here. I will be also online on Monday afternoon, and if there are many more questions, we can do it through the forum on WebAssign or through email and things of that sort. So thank you very much.